All right, everybody, here we go. We have examples of dilations coming your way. Before that, though, I want to share with you this cute picture. It's a picture of Kyla. Whoop. She's terrified. She's terrified that people might be on team graph paper. Kyla likes doing math in team non-graph paper, just like her daddy does. Her daddy being me. All right, so I have some examples for you. And this is examples of dilations, and this is how you'd go about doing these examples without graph paper. First one, we're going to go with y equals 3x squared, and we need to graph it. Let me go grab that cheat sheet that I made from the earlier part of this lesson. I thought I had pinned it on the wall, but I apparently hadn't. It must be right here then. Oh no, it's not. And it must be right here. Yes. Okay, here we are. Okay, so according to this, what we had earlier, this is what we came up with during the conceptual part of the lesson. If there is a number outside of the function, a letter b, that is a vertical dilation by a factor of b. So we have a vertical dilation by a factor of 3. And when we talked before, whenever we're dealing with verticalness, you're dealing with the y-coordinate, and you do exactly what it tells you to. In this case, it's times. So if you take your original xy coordinate, the x-coordinate's going to stay the same, but the y-coordinate is going to be multiplied by 3. So 3y. So if you take the 3 points of, the 5 points, so I'm kind of running poorly on space here. I'm going to rewrite this here. If I have xy heading towards x comma 3y, then with the 5 key points, so -2, 4, -1, 1, 0, 0, 1, 1, and 2, 4. Those key points, the x-coordinate always stays the same, so -2, -1, 0, 1, and 2. Arrow, 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 arrow. And then the y-coordinates are all getting multiplied by 3. So 3 times 4 is 12. -1 times, 1 times 3 is 3. 0 times 3 is 0. 1 times 3 is 3. And 4 times 3 is 12. Then, parent function, I know this is an x squared graph, so we can just simply draw our upward facing parabola, and then you put on your 5 points and you write in your coordinates. So I have -2, 12, -1, 3, 0, 0, 1, 3, and 2, 12. And it works. Okay, that was a vertical dilation by a factor of 3. Example 2, what happens when it's on the inside? So if we have y equals square root of x over 4. Well, this x over 4 is a lot like this right here, this divided by a, and it's inside this function. And when it's inside the function, that means it's going to be a horizontal dilation by a factor of a. So this is a horizontal dilation by a factor of 4. Which means if I take my original xy coordinates, it's horizontal, so it means it's the x coordinate that's going to be affected here. Factor of 4 means you're multiplying by 4. The coordinates are going to be multiplied by 4. Square root graph has key points at 0, 0, 1, 1, and 4, 2. And if you apply this, first, I'm going to multiply all these x coordinates by 4, and it becomes 0, 4, and 8. then 0 stays 0, 1 stays 1, and 2 stays 2. So I have my 3 coordinates. I know that this graph looks like a normal square root graph, so I simply draw the graph. I handwrite in the 2 coordinates. This coordinate is at 0, 0. This coordinate is at 4, 1. This coordinate is at 8, 2. All right, that looks great. So that is a horizontal dilation by a factor of 4. It is affecting the x coordinates. And then this is kind of a story problem where they actually just they describe it. So I have some y equals g of x, and I want to write an equation for a function with a vertical dilation by a factor of 4, a horizontal dilation by a factor of 3, left 6, and up 9. Complicated, but we can do it. Vertical dilation by a factor of 4. It's just like this. It's like this vertical dilation by a factor of b. So that means you're going to be multiplying the function by that b, or in this case, it's a 4. So 4, and it's a g function, so 4 times g of... Now we're going to go inside the function. Now, the horizontal dilation by a factor of 3, as we came up with earlier, a horizontal dilation by a factor of a would mean that it's a divided by a. So in this case, because it's a horizontal dilation by a factor of 3, it's going to be divided by 3. Then, because of the left 6, that would be at negative 6. That means I need to go x plus 6, but on the inside. And up 9 means that outside the function, I go with the plus 9. And that refers to, back to here, the h and the k. That the h represents the horizontal translation, and the 9 is the horizontal, the vertical translation. And that's it. That's it for team non-graph paper examples. And I just want to show you this picture again because it's really cute. Kyla isn't worried about you guys that are watching this. She's worried about people that are in team non-graph paper or team graph paper. We're worried about team graph paper people. We want everybody to be on team non-graph paper. So I hope you liked these team non-graph paper examples. And tomorrow we're going to do a worksheet that's just going to focus on dilations and nothing else. So everybody, have yourself a great Tuesday night. I hope you get sleep in wonderfully and beautifully on Wednesday morning. And I'll see you on Wednesday sometime. Bye-bye.